This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by Lynda.com, the online learning platform with over 3,000 on-demand video courses to help you strengthen your business, technology, and creative skills. For a free 10-day trial, visit lynda.com/knowhow. That's lynda.com/knowhow. And by the Ring Video Doorbell. With Ring, you can see and talk to anyone at your door from anywhere in the world using your smartphone. It's like caller ID for your home. Right now, get free expedited FedEx shipping in time for the holidays when you go to ring.com/knowhow.
Today on Know-How, we get lit.
Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Balacer.
And I'm Brian Burnett.
And happy holidays.
Whatever you celebrate, we support it.
It's the end of the year. This is actually our last show of 2015.
That's right. That's why I got all festive. Because it's not only a holiday, or the holidays are around now, but it's also a special day.
Yeah, but
there's a lot going on today.
Brian, I wanted to talk to you and Alex about this because it's actually
Star Trek Day.
Wars.
Star
Wars.
Star Wars.
Not Trek. Wars. Alex, didn't you tell him this? Oh.
What? Yeah, we coordinated this. Because everyone's going to the movie tonight. We're all excited about it. Everybody's dressing up for it. I've got my Christmas outfit ready for it.
Folks, here at Twit, we try to practice responsible trekking, but evidently it's not going to happen today.
Yeah, well, you already saw the movie last night.
I did. And actually, that's why I'm incredibly tired right now. 'Cause it did go past midnight. I got back to the house about
totally worth it.
Excuse me,
Totally
Brian?
Yeah?
Set phasers to stun, please.
Oh,
Right. Too late. I've already set to kill.
You know, okay. Well, let's get off anything star worthy.
The batteries
and instead
died in
talk
my
about the
phaser.
show. Oh, yes, it should. All right.
It's set to sad.
You are set to sad. Hey, Brian. You know what I like?
What's that?
Holiday season. I like lights.
Yes.
Lights are good.
Well, I mean, it doesn't even have to be the holiday season. I just like blinky lights and just anyway.
Yes, but what I really like are super bright lights. Especially this is like the seasonal. What do they call that? The sad seasonal affective disorder. Basically, when you have less sun, people get depressed and sad and things, right?
During the fall
During
and
the fall,
everything. Yeah, you know, it's raining, it's gray.
Well, we have a video here of someone who may have figured out a cure for sad. Hey, Alex, do you want to show us what a really, really bright LED light looks like? This is what we would expect, right? That's sort of a little halogen lamp. That's not bad. Okay, a little spotlight. Yeah. But you know what's much better than that? How about something that's a little closer to this?
What?
Yeah, this guy he's RC Flight Test.
Oh, jeez.
He built a 1,000 watt. That's a 10 by 100 watt, 90,000 lumen. He calls it a flashlight. That's not really a flashlight.
It lights up his whole neighborhood.
You have to carry it with two hands. I don't think it qualifies
Whoa.
as a flashlight. The crazy thing about this is, I mean, that's just a lot of power. And it only happens because you've got LEDs, super high efficiency LEDs. Oh, no, here's a really crazy thing about this. We could build one of these things for relatively nothing. In fact, Alex, I think I put a link here. These LEDs are not that expensive. I mean, they're going for between 99 cents and $5, depending on the quality and the quantity that you order. In this case, we'd need 10 of these. You can see he's got them mounted on these heat sinks because he has to worry about them melting.
Right, okay.
This is going to generate a lot of power.
And he's only using 2 of those batteries?
He's using 2 5,000 milliamp hour 3S Zippy batteries, which will power that array for, I think he was saying like 5 minutes.
So enough to blind you.
It really sucks down the power. I love this shot. So he's going out in the middle of nowhere. Hi, it's daylight.
Jeez.
I was thinking about maybe making one of these, but then I'm like, I don't know where I would test it. I couldn't turn this on anywhere in San Francisco.
I can just imagine you trying it in your room and then just a bright light shining out your window.
I could like use it as a camera light.
Right.
But you have to turn the iris all the way down on your camera because it just...
People are going to start thinking they're being abducted or something like that.
Well, 90,000 lumen is a ridiculous amount of power.
Yeah, is that like melt your face off?
It is kind of... Well, it would be melt your face off if those were halogen.
Right.
Or, you know, any
but
sort of
they're
incandescent.
LEDs, so...
LEDs, because, I mean, they are far more efficient. they don't generate nearly as much waste heat, which is why you can make a 90,000 lumen flashlight.
Right, but even those LEDs still generate enough heat that he has to slap those heat sinks on there.
Yeah, I mean, I tried one.
You tried one?
And if you have it on for more than about 30 seconds, it will get hot enough to destroy the LED.
Wow, okay.
So you do need to drain the heat away from it relatively quickly. And remember, he also needs a little power converters to sort of boost power for him. You can't just plug them straight into the batteries. That would, again, be a bad thing.
And a good pair of sunglasses.
And a really...
In case you're like, is this thing on?
And then you die.
Yeah, then your eyeballs are gone.
Absolutely. Now, let's move from killer flashlights to something that we want to talk about.
I want to talk about killer flashlights, though.
Well, we'll talk about those again later.
Yeah.
But for now, we want to start the crossover, Brian.
The crossover?
Yeah, because it was announced yesterday that Coding 101 is coming to an end.
Yes.
And the reason why we felt okay with ending Coding 101 was because
I wasn't working on it anymore.
Well, you're not working on it anymore, and if you're not going to be there, I don't want to be there.
That's kind of what I thought.
It's
yeah. Thank
bro
you.
love right here. Come on, that's how we do it. No, but seriously, we're going to expand to 2 know-hows,
Right.
which is nice. And one of the things that we're taking on are the coding projects.
Which I am totally up for. I had a lot of fun programming for the Arduino stuff that we've done, the Raspberry Pi stuff, so I'm more than happy to incorporate more of that. And get Lou. Could Lou come on?
Lou Maresca can come out and play, which is going to be a really nice thing because Lou is, well, he is my personal guru. Anytime I think about someone who knows his stuff, I think of Lou Maresca.
Yeah, it doesn't even have to be coding.
No, it doesn't. It doesn't. Oh, but what I really wanted to do is I wanted to spend this episode sort of being the crossover. We've been doing a project in Coding 101 where we've been playing with digitally addressable lights and the Arduino. So I'm thinking that maybe that might be a good thing for us to start off with.
Well, that makes sense because there were already some crossover segments we did with like Smitty and the soldering and stuff and the clock that he built. So yeah, it makes sense to do some of these projects here.
Yeah. So let's go ahead and start off with a part list, just like we would. That we're going to leave these links into the show notes. These are some of the things that we would suggest you get if you want to do yourself an Arduino project. This is, of course, this is going to be the first thing. Let me pull out all the...
Just remember where they go.
We're going to rebuild it.
It's okay.
It's all good.
All right.
You need one of these. So this is an Arduino. This, well, actually, it's not. If you go to the overhead...
I think we talked about that. Isn't there supposed to be the little infinity
if
symbol?
If this was an official, authentic Arduino, there actually would be the Arduino logo.
Yes.
This is a knockoff.
Right.
Which I feel really bad about using, but, I mean, I can buy one of these for $3 to $4 versus a $20 to $40 for an authentic. So
and you have bought the authentic ones.
I have them. Right.
You have so many that you've actually bought some of these.
Right. Yeah,
maybe you could buy it by accident.
Well, I was talking to Brian Chi about this the other night, and he was saying on a lot of these clones, what they do is they use lower temperature solder.
Right.
The quality of the device isn't great. Like when he is installing into, because he uses a lot of Arduinos for his projects. When he's installing sensors, he always uses authentic parts because he doesn't want a $3 part to bring down a $15,000 project.
Yeah, I remember he was also really excited about, it was like a Raspberry Pi, similar to the Raspberry Pi, but it could handle higher temperatures and stuff like that. But
let's go ahead and let's do the part list really quick. Can you show them the links for this one? So this is where I would find it on the internet. Actually, wait, is that the one that's in there? No? Oh, okay, no, leave it there. So if you were to buy it from Amazon, it's going to cost you about $870. If you go down to eBay and you type in the exact same thing, Arduino Uno or an Atmega 328P, you're going to find it for somewhere in the vicinity between $320 and $380.
Okay.
Yeah,
well,
so you can pick.
You can buy like 2 or 3 of them.
I would buy a lot.
Yeah.
I mean, they're so cheap. Go ahead and have yourself a nice little box full of them because what you're going to find is you don't want to.
You might drop them a couple times.
You don't want to continuously disassemble your project to create the next project.
Right, and if it's not a mission critical project that you're doing, just get a bunch of them.
Right. The other thing you may notice, I have this on most of my Arduino 3D printed boards, is a breadboard. The one I recommended here, it's much bigger than this. This could be your one breadboard device. The reason why you want this is you don't want to be soldering, desoldering, soldering, desoldering. This is a crazy easy way for you to make the connections. And they use these jumpers, these little jumpers that allow you to bridge connections between the Arduino and any components that you may put on the breadboard. That is the best way to do any sort of fast prototyping.
So you don't just tie the wires together?
And put some electrical tape?
Yeah, over them?
That's,
no, don't do that.
That's
Use
awesome.
a breadboard.
Yeah. The other thing I would recommend is to get yourself some WS2812s.
What are those?
These are pixels. Now, this is a pixel stick from one of my favorite places, from Ready to Fly Quads. I mean, this guy really has everything. What I like about these is they are individually addressable. So each of these, and we're going to talk a little bit about what makes them go. I can change each individual LED's color and brightness
That's cool.
with just one wire. So there's only one data wire that has to go to this stick, and I can control it. Now, they make these in all sorts of sizes. I just bought a spool of 500 of them. These are 8 each in a stick configuration. They also have this. This is something else I like. We've got this on a link, Alex. This is an RTF Pixel Circle. This goes for about $10. This is 26 LEDs, and there you go. That's what it looks like. And you know, they're all controlled the same way. I'm going to show you how you can move from one to the next with just a single line of code changed.
Awesome. And can you program the blink in different intervals and things like that?
Yes, we can. Yes, we can. I will say, though, that these are dumb devices. So these are digitally addressable. I can address each individual LED, but it does not have a controller.
Which is why you need the Arduino.
Which is why I need the Arduino, or I need something like this. If you go to the overhead, Alex, this is sort of like those other rings, but you'll notice it has some extra circuitry compared to that. This is an Atmega chipset. So there's like its own little Arduino on the board already. So this is self-contained. I can program this and it will do its own thing.
Right.
If I use either the circle or the stick, I do need some sort of controller to push out the logic to it.
Makes sense. And then so you just connect this to your Arduino, upload the software.
Right. We're actually going to show that process. So we are going to bring you from the start to finish. As you watch this episode, if you've got those parts, if you just follow us along, you will be able to recreate the exact same project.
You'll have blinky lights.
You will have blinky lights, which it's a good thing, right?
Yeah, no, I love that stuff.
All right, let's get started. So what we want to do first is we want to show you how the Arduino environment works, because, well, if you don't have an Arduino environment, none of this will work for you. If you go to my computer number 11, Alex, if you start up the Arduino environment, so you can download this. This is completely free. This is 166. This is what you get. There's nothing in there. It's nice and empty.
Yeah.
But that's the basic components. You need a setup statement, and then you need the program loop. And the program loop is what the Arduino will try to do over and over and over again. One of the reasons why we like programming for the Arduino so much is because the entire community is based on using libraries that you don't have to make yourself.
Right. That means you go onto the internet and download them and
go on the internet,
incorporate them
download
into your
GitHub. Right.
Yeah.
And it means that instead of me having to remake something that someone else may have already made, I will look on the internet and I say Arduino LED WS2812.
Right.
And it will give me a list of libraries that I can load into my Arduino, and suddenly I will be able to use the functions that someone else wrote. So rather than me having to bang out the math, I use the work someone else has already done.
It's like someone has laid out the foundation for you, and then once you get the hang of it, you can manipulate it to the way you want.
Precisely. So let me show you what you're going to do. In the show notes, you're going to find a link for the Know-How episode 173. And in that episode, you will find this. It's a folder. If you go back to my computer, this is a folder that has all the different code examples we're going to give you today. Plus, that very first folder at the top is called Fast LED 3.1.0. Now, that is the actual library. So that contains all the code I need to be able to access that WS2812. Someone else wrote this. I can't claim credit for this, but it allows me to do this. So here is the root directory of the Arduino software that I'm using. In the root directory, there's a folder. If you want to go ahead and zoom in on this, there is a folder called Libraries. If I open this up, these are the libraries that come with the Arduino. And actually, I've already put in the Fast LED library here.
Did you just drag and drop that in there?
All you do is you copy and paste. You copy and paste right into the libraries folder, and the next time you turn on the IDE, it will be able to access that library.
Very cool.
Yeah, so super simple, nothing big about it, all good, right?
Okay.
All right, let me go back on this.
No melting faces.
No melting of faces. Let me shut that down. Okay, so here's what my, oh no, that's a finished example. I don't want to give you that. That's cheating.
Yeah.
So
Don't
this
skip
is
ahead.
what my code looks like right now. What I'm going to do is I'm going to show you a basic way to address the Arduino and the WS2812 LEDs using just a couple of simple commands. So the first thing I want to do is I want to tell my IDE, my integrated developer environment,
Right.
that I'm using the fast LED library. So I'm going to put pound include, and then in quotes, fast LED.h. And yes, capitalization does count, so make sure that you spell it correctly, you capitalize it correctly, otherwise it's not going to work.
It is, yeah, it's very sensitive.
It is sensitive. All right, so the next part that I'm going to do is I'm going to put define number of LEDs. So pound, and then capital num LED, LEDs. And I'm going to put, for this one, 8.
8.
And what this allows me to do is it lets me tell it how many LEDs are in the strand or the array that I'm going to address. And I'm going to show you why that's important just a little bit. But know this, if I were to switch between this, which has 8 LEDs,
And the circle.
which has 26, all I'd have to do is change that number, and it will now be able to address the 26 instead of the 8. In fact, I'll show you a little bit later what happens if you try to use 8 on this, which is, it's really
I was
non-dramatic.
going to just 8
It
LEDs
just,
light
yeah,
up.
it
on
accesses the first 8.
Yeah, that makes sense.
Yeah. All right, so the next part is we need to define the data pin, because I need to tell the Arduino what pin on this board is going to be used to talk to the strand. So I'm going to define
Okay.
my data pin, and it's going to be 7. So I'm saying on data pin 7 on the Arduino, that's where I'm going to be sending commands for the WS2818 to receive.
Okay.
Okay. Now here's a little something something. CRGB, which is a data type that is given to me by the library. LEDS, I'm making an array called LEDS, lowercase, you can tell. And then I'm going to do this, num,
In parentheses.
well, in brackets.
Oh, brackets.
Num LEDS.
Oh, yeah.
What I've just told it to do is I've told it to create an array called LEDs, the size that I indicated in num LEDs, which is 8. So I've told it to create an array with 8 cells.
Right.
Okay?
Okay, that makes sense.
All right, and I'll explain why that's important later on.
You've defined num LEDs, LEDs, as 8. Okay.
As 8. All right, now let's go to the setup. The setup sort of creates the variables and the environment that I'm going to need to run my program loop. And go back to my my program screen, Alex. What we need here is we just need one line. It's fast LED dot, and you'll notice that when I put a reserved word, so this is a function that was given to me in the library, it changes color. So
Right.
it tells me it knows what that is.
Okay.
I'm going to put add LEDs, add LEDs, and then I'm going to say NeoPixel, which is a type defined by the library. So now it knows what kind of LEDs it's going to be accessing, comma, data pin, so it knows where to access that,
Which is number 7.
right? And then LEDs, which is the name of the array that it's going to be accessing, and then the number of LEDs, which tells it that's the number of LEDs it's going to have control of.
Right. And so what's cool about the way you're programming that too is that if you change that number at the top, you don't have to change it anywhere else because it's always calling to that number.
Precisely, exactly. And you're gonna see this several times. We can hard code a bunch of these variables. Like if we're really lazy, we could have just put 8.
Yeah.
But the problem is if we ever change it, we have to go back to the program and
The
find
whole thing.
all the pieces where we put 8 and replace them.
That's just good programming. Bob,
That's
right?
horrible programming. I mean, you can do it if we've got 10 lines of code, but
Yeah.
I mean, if our program goes 100 lines, 200 lines, 400, 1,000 lines, 10,000 lines,
Yeah.
you kind of want an easy way to do it.
Yeah. No, that's smart.
Okay. So actually, here, go ahead and play with this for a while. I want you to hold on to the LEDs.
Not much I can really do with this.
Well, I mean, yeah, because you don't have your code yet, right?
No,
And
it's not even
we
plugged
want
in.
your code.
I do want my code.
You do, exactly, which is what we're going to do now.
Okay.
So I've done this. If you come back to my screen, in the program loop, the first command you see is fast LED clear. What that's going to do is that wipes out the strand.
Makes sense.
Right, because you kind of want a blank slate. You don't
Right.
want any of the commands from the previous array to stick around inside the strand.
Right.
So I'm clearing it. Then notice what I'm doing here. This is how you fill cells in array. LEDs 0, 1, 2, 3, 4, 5, 6, 7.
So 8 LEDs, but
8
starting at
LEDs.
0. Yeah.
That's the array that I created up here. Remember? I
Right.
did this. So I created that array. Now I'm filling each of those cells.
with a color? Is that what those
That's
are?
what a color. It's a hexadecimal color.
Okay.
Now, here's the beautiful thing. This is how a WS2818 works. I have now filled that array with those colors, and what it will do is it will combine it with this. This is how bright I want it to be. And this could be from 0 to 100. So 0%, 100% brightness.
Okay.
And then when it gets to this fast LED show, what it says is take the array I just created,
And display it.
which includes those bytes. So it's the bytes of what colors to send,
Right.
and then display it down data pin 7, which I defined earlier. It says send it
Right.
all down data pin 7, and those LEDs will receive the commands.
And then the following command is how long it stays on.
Well, yeah, how long
that-
it's going to wait until it continues down the program loop.
Delay 200 milliseconds? Is that what that is? Or-
Precisely.
Okay.
So what we're going to see now is when I send that array, so it's going to be sending 3 bytes for every single one of those arrays. Each of these LEDs has, along with the LED, it has a little bit of logic. There's a little IC in it. It will take the first 3 bytes off the stack. It will use that to set its color and brightness, and then it will pass everything else onto the LED behind it.
Okay.
And that LED will take 3 bytes off the stack, set its state, and then pass everything else to the LED behind it. And it keeps doing that until there's no more bytes.
Okay.
When it's done, there's nothing left to pass. The last LED receives 3 bytes. It says, oh, there's nothing left. I'm going to stop.
And then that's when the loop starts again?
And that's what the delay would start.
Okay.
And the delay's 200 milliseconds and then moves on.
Cool.
Okay. Now notice quickly what I did here was I have 2 different sets. I have this, which gives me hexadecimal for, I think it's red, green, red, green, red, green, red, green. Or no, green, red, green, red, green, red, green, red. And then this one, which does the opposite.
Okay.
Red, green, red,
yeah.
green, red, green, red, green. And now here's how we program.
We throw everything on the
Just
floor.
throw it on the floor, and we're like, I'm done with you.
Yeah, now I know why you keep buying all these
Because
Arduinos.
I keep breaking them. I'm a bad man. All right, so actually, I'm gonna pull all this stuff out to make it super simple. I know, now I have to remember where I put that. Okay, let's look at this, Alex. There we go. Okay, so I've got my Arduino here, if I can get into the camera. I need 3 things for my LED. I need power, and I need data. I've soldered on these jumper leads. I've got black is my ground, orange is positive, and then this is my data pin.
Close enough.
Right, and there's actually those pins here on the Arduino. So I'm gonna put ground into ground. And
Yeah. It's hard to see on the camera, but there's little words.
there's a silk screen, right. And then, do you remember what data pin I was using?
7?
Yeah, that's right. So I put that into data pin 7. Now I need to connect this
It looks
to...
like you have them both in ground. Is that what you want?
Oh, there's 2 grounds.
So do you want one?
Ground
in the-
1, ground 2. So that's ground, and that's in 5 volt.
Oh,
Trust me on
okay.
that. That's
All
good.
right, I believe you.
Okay, so I'm going to plug this into my computer. It's just USB. And now what it's going to do, if you go back to my computer, it's going to tell me that I've got an Arduino on COM port 5. And I also have to make sure I have, I'm using the right, the right board. See, I was set for a Nano or a Pro.
Yeah. You
So
have to set up your ID for the Arduino
The right one,
that you're
right?
using.
So there's the Arduino Uno. There we go. Now, when I want to program, quite simply, I push this button. Go to the overhead. There's a button next to my USB port. This is sort of like the reset. So I'm telling the Arduino to get ready to receive commands.
Oh, okay.
And then in the IDE, you go back, Alex, I push this little upload button up the top here. And what it's going to do...
You can see a little green bar at the bottom. Yeah,
right,
it's
right.
Uploading.
It's compiling all my code. So it's looking at the library. It's saying, all right, this is what you called. This is what you asked me to do. I'm going to turn this into a binary that the Arduino can actually understand. When I get those 2 white lines,
Yes.
it means, okay, it's good. Now
if
it's
you don't
up.
see the white lines, it means you did something wrong.
It means you did something wrong.
Yeah.
Right. Yeah.
I've seen the like I think it's red.
That's- yeah,
Doesn't it
that's-
come up
that's
red?
bad. Yeah, we don't want that. So what we've got now is we've got the ability to, hold on.
Moving pins around again, huh?
No, I kind of shorted these out. That's my, that was my bad.
That's what happens when you do live demos. So.
Hold on.
It's all part of
There
the
we go.
experiment. There we go.
There we go. Okay, so now we've got my LEDs. Go to the overhead. Bring the light down a little bit. There we go.
Oh, look
Don't you
at
feel
that.
Christmassy?
I can hear the sleigh bells in the background. That's
Right.
awesome.
And so the way it's working is that loop is just repeating itself over and over again. That's what the
Right.
Arduino does. It's just going to keep doing what's inside that loop function.
And you can mess around with that loop setup.
I
You can make it more
I could
complicated,
do more
less
colors. I
complicated.
could do more arrays.
Yeah.
But right now, all it does is it sends commands over and over to this little strip of LEDs saying,
Mm-hmm.
do red, blue, red. Oh, red,
Red,
green,
green.
blue, green, blue, green, blue, green, blue. Then blue. Then the opposite.
Red, green. It's almost like you went and saw Star Wars last night.
Right.
It's yeah, it's red, green, red, green, red, green.
Red, green,
and
red,
over
green.
and over. And then you have another one that does the exact opposite, but it's gonna
Yeah,
look
so
the
they're
same.
just alternating. They're going
Yeah.
back and forth. But this is cool, but this is kind of boring because I have no control. Once I hit the program, the speed and the brightness and
It's
the
all
type of
set.
it's all set.
Yeah.
What we want is we want a way to push in your real-time commands.
On the fly.
Right. Which we're going to show you in just a bit, but first, we do want to thank the first sponsor of this episode of
Yes.
Know How. And you know who that might be?
I'm trying to remember. Yes, it was Linda.
It was Linda. You know, we often talk about knowledge here.
We do.
Specifically
we do.
about a phenomenon that happens to know-it-alls.
Well, we love to try and fill the knowledge hole, but there's only so much we can do in now what is supposed to be half-an-hour segments.
Which we totally blowing
But
past.
this is the last episode of this season. We'll call it the 2015 season.
2015.
Yeah.
Well, folks, if you do want to fill that knowledge hole and you're thirsting between episodes of
If
Know
you want
How,
to learn more about Arduino.
if you want, actually, yeah, they do have a course on Arduino. It's lynda.com. Lynda.com is the one-stop shop, the repository of all knowledge on the internet. It's for the makers, for the doers, for the curious, people who want to make things happen. Maybe you want to learn how to take better photos. Maybe you want to master Photoshop. Maybe you want to sharpen your Excel skills. Or maybe you do want to learn Arduino programming. Lynda.com has something for everyone. Now, if you are interested in programming, creating an app, or developing for the web, new Lynda courses that I can recommend right now would be Node.js Essential Training, Programming iOS 9 and Gameplay Kit, Up and Running with COBOL, and Programming for Non-Programmers. That's actually a big one. Now, whether you're a beginner looking to learn the basics of coding or an expert looking to master a new programming language, Lynda.com has something for everyone of every experience level. With the Lynda.com membership, you can watch and learn from top experts who are passionate about teaching. You can stream thousands of video courses on demand, and most importantly, you get to learn at your own pace. It's not you trying to keep up with the course material, it's the course material coming as you need it. They give you transcripts, so you can jump specifically to a part of a particular lesson that gives you the answer to a puzzle. You could look at your playlist to find out what you've been learning and put it off. Stop, pick up something else. It's how your mind works. If you learn when you're interested, you'll retain the information, and that's what lynda.com understands. You can also download the tutorials, and you can play them later on your iOS or your Android devices. And you get to stop and pick up where you left off on your Mac, your PC, your Android, your tablet, your phone, your desktop, wherever it may be. Lynda.com has a way for you to watch. My personal favorite feature is the fact that I can save my playlist and share them with friends so they can know what I'm interested in right now. So I could say, hey, Brian, here's this really cool Arduino course. Take this, just watch it and see if maybe you might want to do this.
Well,
Might be kinda fun.
I would like that. And then the other feature that I really like is going back 10 seconds, especially when you're doing programming
What did
or
you just
something
say?
like
Wait,
that.
no, what?
Yeah, because you're sitting down with your computer watching the video, and then you're like, I just missed that. Hold on 1 minute, and you go back 10 seconds, and it worked great.
Yeah. Your lynda.com membership gives you unlimited access to training on hundreds of topics, all for one low flat rate. Whether you're looking to become an expert, you're passionate about a hobby, or you just want to learn something new, I want you to visit lynda.com/knowhow and sign up for your free 10-day trial. That's lynda.com, lynda.com/knowhow. And we thank lynda.com for their support of Know How.
Set your phasers to learn. No?
No.
It's Star Trek Day.
No.
I love Star Trek.
No.
I love Star Wars.
Okay, well,
All right,
folks,
moving on.
We're going to have to fix this because obviously there's something wrong with both my director and my co-host. So we're talking about lights. I'm thinking maybe we want to show you a little something in a non-visible spectrum, which is why a few months ago I stopped by Las Vegas and I had a chance to check out some FLIR. If we're going to speak about the next level of drones, one of the things that we have to discuss is the technology behind infrared. Infrared is one of the hot topics here at Indradrone 2015 in Las Vegas, Nevada, because it allows our machines to see things that visible light just can't do. I'm standing next to Jeff Frank from FLIR. He's the Senior Vice President, who's going to tell us what makes their technology so good.
Well, it probably starts with experience. The company's been around for probably about 50 years. Have been developing the technology from day one, bringing it up. We control the entire vertical, every aspect of the manufacture of these cameras, from the sensors, the very lowest level part of the sensor, all the way up through camera systems and very high-end gimbal systems for airborne platforms and that sort of thing.
You actually have a product here that can fit on a drone that is, what, $1,500, very affordable, and yet can still give me quality images.
Absolutely. It's one of the things that our company has always pioneered in doing, is bringing the cost of the technology continually down to be able to reach larger and larger groups of customers. It's one of the things that's just fundamental in our DNA in terms of how we operate our business. The one that I will say that is new to us, that drones has brought us, is the agricultural side. That's not been an area of business that we as a company have been involved in, but what we've watched over the last year is the value proposition that thermal imaging brings to agriculture. And I'm not an expert in this area, and I don't want to claim to make any claims here, but from what we've understood from our customers, that there is a direct correlation between water levels in agriculture and your ability to detect that with thermal imaging and the heat that's radiating off a field. So it makes it's really a great natural for what we do. So at the bottom line is, pretty much every business that we're in, drones is an extension of those businesses. We're in the firefighting business. This is a spectacular firefighting tool. When you add this to a drone, now we've got a completely new value proposition for firefighters. We're in the building inspection business. We build handheld cameras that do that. You put one of these cameras on a drone, you've got now a much better ability to do a building inspection from the outside and do a 3D map of a thermal map of an image of a building in a matter of minutes. So the technology and the value propositions that's bringing to all these markets is really profound.
What should I look for to tell me, yeah, this is a product that's actually going to work when I get to 300 feet, 400 feet, 600 feet?
Well, there's a couple of things you want to look for. I mean, with respect to thermal imaging, one of the key parameters is sensitivity, the ability for how small of a temperature difference can I measure. These cameras are capable of about 100 millikelvin or even smaller temperature differences. That means it can detect that small of a temperature difference on the ground. So sensitivity is a very key issue. Another one is resolution. How many pixels do you have on the scene? The image we see behind us on the screen here, that's got a 640 by 480. It's a little bit different than the visible world, where a 2 megapixel or 4 megapixel is kind of old hat. In the thermal world, a 640 by 480 is pretty much a state-of-the-art kind of sensor in the commercial world. So you want to be looking for that. But really the most important thing, the years and years and years and years of experience for what you do from a signal processing standpoint, to take the output from these detectors and apply the right automatic gain controls, the right uniformity correction processes, all the signal processing that goes on behind the scenes that gives you image quality like that. There's a lot of other people out there building cameras right now, but if you actually put them side by side and look at them, you see fixed pattern noise, you see just non-uniformity in the scene. You don't see that in our cameras.
Jeff, let's go ahead and give them the brass tacks here. Pricing and availability. If they want to get into drone-mounted IR right now, where do they go? How much will these cost? When can they get them?
So where to go? I'll start there. Go to our website, www.flir.com. In terms of pricing, in June of this year, we actually introduced the first version of this product, which was called the FLIR View. And that product was introduced at $14.99. That was the lowest price camera in this class by a very large margin. In this show, we've introduced the FLIR View Pro, which adds a tremendous amount of new capability in terms of data recording. It really turns this into an instrument now, a scientific instrument that allows you to collect data for mapping applications and that sort of thing. This is priced at $19.99 for the 320 by 240 version. A 640 by 480 version will add around $1,500 to that price.
Jeff, I want to thank you for speaking with us, and I'm Father Robert Balacer. The future is in IR.
I know there's a lot of people in the chat room going, $1,500 that's not affordable.
Yeah, but compared to what it used to be?
Compared to what it used to be, and you have to remember the applications for this is where drones actually start to get useful. They're no longer toys.
I think they're useful.
They had an incredibly cool demo at the FLIR booth where they were using a drone. It was just a Phantom. It was a Phantom 3 that had the FLIR sensors, the high-end FLIR sensors mounted on it.
Right.
And they did a 3D, like a fly around a building, And from the thermal images, they were able to make a 3D representation of like where all the energy was blossoming out of the building. I mean, that's incredible.
That is pretty cool. 'Cause what would that have taken just 10 years ago?
You're talking like $1 million worth of specialized equipment. This is, what, $3,000 worth of drones
So
in FLIR.
in that sense, it's affordable. Not that I'm gonna go out and buy one.
Yeah, I mean, if you can afford to go out and buy one right now, then you're doing much better than I thought.
If you're the kind of guy who's going on eBay and buying all the knockoff Arduinos, you might not be getting this.
No, not so much. Not so much. But actually, we are getting some FLIR gear.
What?
Yeah, so we're going to be playing around with it a little bit. I do want to see, one of the things that was promised to me that will change agriculture forever is that some of the new FLIR gear you can send on like an automated drone that does a quick lap around farmland. And because the thermal bloom that you get off of crops is dependent on the amount of water that's being released by those crops, you can determine exactly where you need to water. I mean,
yeah, where the dry spots are and things.
That's incredible.
That's gonna be crazy.
Yeah. But let's get away from the crazy and go back to the crazy.
The other kind of crazy.
The kind of crazy. The kind of useless crazy.
Padre
Useless
crazy.
but fun. Crazy.
Yeah.
We're going to be doing a little extra now because we've found out how to make the Arduino do things with lights.
Yeah, we set up the really basic stuff. Now, this looks like you've got more hardware on the table.
Yes, we've got more hardware on the table, and we're going to be doing some inputs as well. But before we do that, Brian, you know what I want to do?
What's that?
I want to thank the second sponsor of this episode of Know How.
I know exactly who you're talking about.
Who is it?
Ring.
It is
the
Ring.
video doorbell.
The Ring video doorbell. Now, if you remove your phaser and take it from being set to kill,
see that.
there you go. Show them what's in this box, Brian. Now, this is the Ring video doorbell. Just like the name may sound, if you go ahead and push that bell.
Oh, don't mind if I do.
There we go. We love that tone because that tone means there's someone who wants to speak with us. And Brian
Well,
I are
and you
both
can
very
change
warm
that
people.
tone too.
You can.
Which
you can.
I appreciate because my dog flips out every time he hears the doorbell.
Precisely. Now, what the Ring video doorbell is it's a way for you to turn your house into caller ID. Yeah, that's how it works. When someone rings the bell, it actually starts a session with a mobile device, your phone, your tablet, whatever it might be, and you can have a two-way conversation. You get to see whoever's at your door, plus you can speak to them and you can listen to what they're saying. Now, the way it installs is with this kit, and it includes everything you need, everything from the drill bit to the level so you install it properly to this. This is a little mounting plate so that you can run the Ring video doorbell off of your house current, those two wires that you currently have going to your doorbell. If you don't have a doorbell, if you have one of those houses that's always used a wireless setup, don't worry about it because they give you this little cable. So just micro USB. You can charge up the internal battery and it's good for a year. What it does with that power is, well, kind of phenomenal. Now, Brian, we've seen this demo before. This is, I like Ring because I've actually bought one.
Yes.
Before they
you
were a
have
sponsor for TWiT.
You have it on your parents' house.
I do because I worry about my parents. And especially now in this season, we've all heard the stories of
Packages being swiped off the deck.
packages being swiped off decks, right? Or people looking in houses because they know they might be loaded with gifts.
Or they're gone for the holidays.
They're gone
I just
for
watched
holidays.
Home Alone. You know how that whole movie would have
Home
ended.
Alone would not have happened
with the Ring video
if
doorbell.
Macaulay Culkin had the Ring video doorbell. Now, check this out. So this is how it works. This is the screen. Oh, let me put it right side up. There we go. This is actually the actual device that's at my parents' house right now. So for example, push this. This was a missed call.
We have not checked this beforehand. This could be
bad.
your dad running out in his boxers.
Wait, which way is up?
There you go.
There you go. Okay. So, who is that?
Hey, that looks really festive out there.
Oh no, yeah, my
There are a
parents.
lot of lights going
actually,
on.
I programmed a strip of WS2818 lights the last time I was there. So go figure. But here's the cool thing: it will record this and it will send it up to the cloud so that we can check the video later. If someone was scanning the house, if someone was coming by to see if maybe nobody's home, and we see it again and again and again, we can catch them with this. In fact, this doorbell already caught a package thief across the way.
street, yeah.
It saw the UPS truck pull up, which triggered the motion detection, so it started recording. And then as soon as the truck left, a white truck pulls out, a woman gets out, grabs the box, throws it in the back of her truck, and takes off.
Yeah.
Well, because of my Ring video doorbell, we were able to show the police what the truck looked like and what the woman looked like. Folks, this is the peace of mind that you get. Why not try the device that Time Magazine called one of the 10 best gadgets? You can get a Ring video doorbell, you can get a peace of mind, and you can get an incredible piece of technology. This year, give the gift of peace of mind and convenience with the Ring video doorbell. Go Go to ring.com/knowhow. That's ring.com/knowhow for free expedited FedEx shipping. That's ring.com/knowhow. And we thank Ring for their support of Know-How.
Thanks, Ring.
Thanks, Ring. All right, so we're going to step it up a little bit. You may notice that we've changed our model a little bit. If you go to the overhead, we've gone from that the black one with the analog knob there that I used on a previous Coding 101 exercise to this white one that's using 2 PWM controls.
Right.
And the reason why I'm using PWM is you may have heard of PWM on Know-How before.
We did talk about PWM. Wasn't it for the propeller motors on the quadcopter?
Well, it's for everything on quadcopters, for remote control models.
Right.
We work on PWM, that's pulse width modulation.
Right.
So
we talked about digital versus analog.
Right. So this is analog, and on an analog potentiometer, as I turn this, it will either increase or decrease resistance, so the amount of voltage that actually makes it to the pin will be increased or decreased.
Right.
Now the Arduino can read analog just fine, and it can convert that into 1023 different levels that it can read. But what I get with PWM is I get more accuracy. There's far more levels I can use, but also the ability, if I design my device to use PWM, to say replace these 2 potentiometers, PWM encoders, with, I don't know, maybe the receiver for a remote control aircraft.
Oh, well, hello there.
Hello there.
What are you going to do with that?
Oh, I'll show you later. But first, let's look at the code that we're using for this.
Okay.
You'll notice it does look a lot different. There's more here than there was before. This first part is the same. So it's including the fast LED library, telling it that there's 8 LEDs in the strand, telling it that my data pin is 7, telling it that I want it to create an array called LEDs. That's the size of the number of LEDs in my array.
Yes.
Everything below this is way more complicated.
Yeah.
A little bit.
Looks like you have some comments there to help out.
Yeah, and actually, folks, don't worry about copying down from the screen because the final version of this program, it's ridiculously commented. I told you exactly what every single line does, which means you can tinker. But okay, let's look at the setup. Remember, we said this. It starts with the setup. There's a few extra things here. This line is the same. So I'm just telling it that I'm going to use a fast LED library. I'm telling it how many LEDs I have. I'm telling it what array it's going to use to push that data out to the string.
Right.
But then down below, I've got this pin mode. And I'm doing pin mode, pin 1, pin mode, pin 2. What I've done is I have set mode on 2 of the digital pins to read.
And that's for the little dials.
Those are for the dials. So up here, you'll see pin 1 is 6 and pin 2 is 5.
Okay.
So I am telling the Arduino, I want you to read from pin 5 and pin 6. And I'm going to be using those values.
All right.
All right. The other thing here that we did not see in the other one is serial begin 9600. This tells the Arduino that at some point, I'm going to push data to the serial port and I want it to print it for me.
Yeah, we didn't have to worry about that on the last one because once it was set, but you couldn't change it. So.
Precisely, right.
Okay.
This allows me to debug. I can see what's actually going on inside of the program that I wrote.
Cool.
Okay. Now let's go ahead and look down a little bit. We've got this in our loop. This looks a little weird. Remember how I said I don't like hard coding things? I like to put them in variables so I can change them later on.
Right.
What this is doing, this is allowing me to set the high and the low values for the PWM devices that I'm using.
Okay, why are they different on each device?
Because some cheap-ass PWM devices.
Okay.
Okay. All right, so let's do this. We're going to open up our serial monitor. And what we should start to see from here is this. I have mapped out both of the PWM devices. So on the leftmost side, that is the raw data coming in from the first PWM encoder. The next column is the remapped value of that PWM encoder.
0?
Which is 0, right. Everything is set for 0 right now. Then the third one is the raw value coming from the second PWM encoder. And then the fourth one is the remapped data coming from the PWM
okay.
encoder. And I will tell you what raw and remapped is in just a bit.
I think I know what you mean, but I'll let you get to it.
So look, let's check this out. So this right here, let's go back to the, when I have this all the way off, so 0, see I'm seeing zeros in those columns?
Right.
I'm noticing my value is fluctuating between like
8, 900,
94.
600.
Yeah,
That's weird.
Yeah, precisely. The reason why that's doing it is because, well, all electronics are going to have a little jitter in them, and this is really crappy electronics, so it's got a lot of jitter.
Did you get these off eBay also?
Yeah.
Okay.
These were about 25 cents each. Okay, but if I go all the way up to the top, I go up to, looks like 2,000?
Yeah, right around
21.
2,100, 2,000.
Right. Which is what I set inside of this. Notice how I set my low value at 900, my high value at 2091. Okay.
And now you have 100 on the right little column.
And now this one I configured, because on my low side, I am like 10, 20, 10, 15. I think that's my lowest, right?
Okay.
And then if I go all the way up, I go all the way up to 2016 or so. 20, that's about my high mark. 2000 is what it hovers around.
So the Arduino is just receiving the voltage? Is that how the
It's receiving how long it stays high. So the way a PWM device works is there's a clock cycle,
Yeah.
right? And it counts how long is a single high versus how long is a single low.
Oh, okay. Okay.
Yeah, so this is just counting the high side. I could tell to count the low side,
Yeah.
and that's actually commented in the program. Don't worry about that. But I'm just counting the high. And the reason why I'm doing this is so that I can get a value that I can actually use.
Right. You want a 0 to 100 value.
Right.
Yeah.
Someone in the chat room asked, why didn't I set the brightness at the top of my program? There was actually a reason for that. The reason for that is I actually want to be able to control brightness.
Right.
So I'm going to set it down below. If you look at this, go to the overhead, or go to the side view. So that is the strip of LEDs that is being controlled by my controller right now. Because I designed the program the way I did, I have two things that I can control. This first knob, this PWM encoder, controls brightness. So I can increase or decrease brightness. This second one controls the delay between switching back and forth. So I can go up and down in brightness all the way from 0, so that's no brightness, all the way up to 100%
100.
intensity. And on this one, I can go from that. There's so little delay right now. The cameras can't even pick up how
You
fast
can
that cycle.
barely see it in person,
Right.
but yeah, it's flickering.
In fact, instead of red or blue, it looks
It
purple.
looks, yeah.
Because of persistence of vision, right? But this allows me to control how fast I'm going back and forth between my two arrays.
Right.
The other one controls how bright it's going to be.
Cool.
All right. Now let's see how I did that. Go back to my screen, Alex. Notice how I did this first. The first one is PWM input. So that's a variable I just created. PWM input equals pulse in. It's counting the pulse. Pin 1, which was set for pin 6.
Right.
High. Count the high of pin 6 using the pulse in function.
Right.
And then put that value into the variable called PWM input 1.
1. And then you have remapped map PW1, PWM low 1.
Right. And let me explain
Okay.
what that means. Okay, don't get crazy. Again, I'm commenting the heck out of this in the finished code. But that value does me very little good because this first one is controlling brightness. And we already know from the first example, brightness goes between 0 and 100. But if we look at the raw data, let's open up the serial monitor, I'm going between, like, what was that? Wrong one. I'm going between 900 and 2100.
Right.
That
okay.
would mean nothing.
Yeah.
The thing wouldn't work. So I
wouldn't
have
know.
to somehow take those values and I need to turn it into something that I can use.
Right.
That's what remap does. Here, so follow my logic. Look at the screen here.
That makes sense.
Remap. So the command function is called map. Take the value of PWM input 1. So that's the value that we got off of the pin, right? And then look at the low value set in PWM1 low, which I set for 900.
Right.
And the high value I set for PWM high 1,
Which is 2091.
2091, and map it between 0 and 100.
Right.
So it will do all the math for me.
That's cool.
It will find out within that range between 900 and 2091, where do I say those numbers equal 0 through 100?
That is neat.
Which
Cool.
is why, if we look at the serial monitor, the remapped numbers, which are right here in the second column, they go between 0 and 100. That I can use. That I can drop into the program, and it replaces the brightness.
Sweet. Yeah, because you can see at 1700, that's about 70%
Yeah,
of between those values.
precisely.
Cool.
Now, the second one is easy. I'm going to do the same thing. I'm inputting from a PWM device, pulse in, pin 2. I'll count the high, and then just like before, I remap it. But this one is the delay. Remember, we have the delay in the program, right? Well, in the last version of the program, I just put delay equals 200.
Yeah, so it was a hard set.
It was a hard set, static. It was always going to be 200. Here, I can change it because it's set by the remapped value of pin 2, which is actually pin 5.
Which is between 0 and 500 now.
So at 0,
it doesn't do anything.
Well,
It
so
stays on 1.
remember we set the low, right? At 0, the low of 1015. So when it hits 1015, there is no delay. It just keeps going and going and going. At the high point, which is 2010, because again, Alex, if you show it, that's what we set here, it's going to have a delay of 500.
Right.
And if you look at my monitor screen again, that's exactly what we get. We don't quite get down because I didn't want to get it to complete 0 because bad things happen. And then on the upper side,
so this is
get up there 500.
500.
There we go.
That's why it looks so slow. Yeah.
That's why it's so slow, because it's waiting 500 milliseconds between pulses.
And then
Or
when you
500
go to the other
clocks.
one, yeah.
Yeah, and the other one will
gets
control.
super speedy.
Right. Actually, let's take it down a notch. There we go. Oh, so much nicer. Okay.
Yeah.
So this is what we've got.
Cool.
This program will allow me to control 2 different things. I can control brightness and the delay between the loops.
Nice.
But, and we're running out of time here, so I'm gonna go to the coup de grace.
Oh,
I know, that's French.
fancy.
It's very fancy. So what we've got, let's pull this off. These are nice because, well, they allow us to play a little bit. But, oh, actually, you know what I want to do? I do want to show this.
The ring?
Let's show the ring, because the ring is pretty cool. And it also shows one important thing that I was trying to tell people about earlier, and that is
The changing of the variables?
the changing of the variables. So let's do this. Wait, what?
Which one do you want to do?
I think I want to do this one. Yeah, let's do this one. Okay, what I'm going to do is I'm going to change these over. I'm just going to replace the pins from the 8 LED with the pins from this. So I have positive, negative, and data.
And this is where the breadboard comes
This is where the
important.
breadboard comes in really handy, because all I got to do is pull these out. And so I've got my data pin, which I know is pin 7.
Right.
I've got my negative, which is on my breadboard. And I have
Does
my
it say
positive.
negative on the breadboard?
Well, no, that's what I did.
Oh.
But
I
if-
was just wondering.
If you look at that,
Yeah.
go ahead and go to the overhead, Alex, and then drop the lights a little bit. Because I set my number of LEDs as 8, it's only controlling the first 8 of the ring.
Which makes sense.
Yeah, but
But
go
the
to my
delay
code.
and the brightness still.
Yeah. Go to my code, Alex, and this is how I fix it. So when you get my code, this is how you modify it to work for any number of LEDs you have.
Right.
I'm going to put number of LEDs equals 26. Sorry, 26.
It's getting a little crazy there.
I know, crazy. So the cool thing about this is the software will just automatically, because I use the number of LEDs variable, it will automatically fix itself.
It'll attach those to the array.
Correct. So let's do this. Let's go ahead and upload. So it's going to compile the sketch. Keep going. Little laptop, come on, you can do it.
So
You can do it.
it can upload the new
Updating. There we
new
go.
software while it's still running.
There we go. And now, what we got, oh, I have to reset it.
Yeah, do you have? Isn't it like called bootloader mode or something like that?
Yeah.
Or boot mode?
Hold on. Oh, wait, you know what I did?
What'd you do?
I may have broken it.
Well, I was wondering, do you have to reset it, upload the code?
It didn't reset properly.
Oh.
Come on, you can go.
You can do this, Arduino.
You can do this, Arduino. You got this, Arduino. Oh, there we go. So it has to stop.
Right. And then.
Oh no.
Oh,
No, I busted my code.
The code's broken.
Yeah. You know what? I put a static entry in here somewhere, and now it doesn't want to let it go.
Well,
it's
That's what
okay,
happens
'cause it's
on
going to
live
show it off
demo.
in the next example. Because
Yeah.
we're running out of time. I do want to show you this. This is a project that I think you're going to like because it's very Christmassy, and it's something you can do for almost nothing.
cool.
I got these off of Amazon. Alex, if you go to the link for these, about $18. These are not WS2812s. These are WS2811s, but they work exactly the same. They work with the same library. And these are Christmas lights. These are things that you can hang outdoors, to play around. And again, these all work off of 5 volts. I would not power this off the Arduino because it pulls way more power than the Arduino can supply, and you will end up smoking something.
Okay.
Or at least just shutting it down. But you'll notice this. Look at my Arduino.
He's a little bitty
It's a
guy.
little Pro. It's a little teeny tiny Pro. This is using the exact same chipset. This is the 328 at Mega Chip, but it's a much smaller. This is the Pro package. There's also a Nano package. But I built this, I actually assembled this last night, because I wanted to be able to control the entire string of LEDs from a very small device that I'm going to put into a little 3D printed enclosure and put outside.
Right. And then you're not pushing power through that, so
Right.
Good.
So what I got is, let me turn this on, and then engage power.
and that's going to the little.
That goes to the little guy, and the little guy is going to start controlling the LEDs. There we go.
Awesome.
But there's an animation library on this. And let me show you what this looks like. You're gonna like this. This is cool stuff. I did not write this.
I can't look away
'cause
from
I got-
the LEDs.
I got bored and I stopped writing.
Pretty.
But this was created by a author, a programmer by the name of Mark Kriegerman, back in last year, December of last year. And what he did was he created a little animation library using a bunch of the different features of the Fast LED library to do everything from there's follow lights.
Oh,
there's-
that's cool.
Right?
That
How
is
cool
awesome.
is this? And this is run all off of the Arduino. Now go to my code screen. This is what his code looks like. So he's got all the same stuff. He's defining data pin. He's defining color origin.
Right.
He defines his brightness up top. But you'll notice everything in his program is static. There is no control. I don't have any knobs,
No,
so I
it's
can
set.
adjust brightness or delay. So what you can do, and again, this is going to be included inside of the show package that you can download when we're done with this. Go ahead and take the code from my programs that let you do external inputs and put it into the code for his program. So you can control the speed of the animation, the brightness of the LEDs, or, and here's a challenge for the folks of you who are true programmers, take it, use it with something like your FlySky remote and one of your receivers, and you can remotely toggle between animations.
That's cool.
Because he's got 7 different animations in here. You could actually use the position and a
Of
bunch
the
of
throttle.
if-else statements to say animation 1, animation 2.
So at
animation
50% you do this animation, at 75% you do that animation.
Precisely.
That's
precisely.
cool.
And this string is going to come with me because I can power this entire thing off of this USB battery. I have this USB battery. It can power both my little Arduino and the string of LEDs for 12 hours.
That is cool.
This will be my mobile Christmas display, no matter where I go.
So is that why you're going to just wrap it around yourself? You're going to be your own little Christmas tree?
I'm celebrating 2 masses for Christmas Eve and 3 masses for Christmas Day, and I am going to be the most colorful priest you've ever seen. But I'm going to put it underneath my vestment so people don't know what it is. Why does he keep lighting
Why is he
up?
glowing? He looks so lumpy. That's weird.
I normally look lumpy, Brian. Thanks.
That's true, but at least you'll be colorful this time.
So sad. So sad. Okay, folks, we know that was a lot of material, and but we
That was
wanted.
fun.
Yeah, this was fun, and remember, we're bringing this over from Coding 101. We're not going to have a lot of the super high level stuff. What we want to bring you coding challenges that have hardware in them because we
Yes.
understand you're more hardware.
This was just below the level of my face is now melting because of the program.
Precisely.
Yeah.
And here's what I love about the Arduino. Unlike the Raspberry Pi, you're not going to corrupt the file system. Worst
Right.
case scenario, you hit the reset button and you upload a fresh batch of code.
Yeah, no big deal.
And the Arduino IDE is really good at telling you where you have errors. In fact, here, let me throw an error in here just so you know what it looks like. So go back to my screen. I'm going to mess up, and I'm actually accidentally, this happens all the time. I'm going to forget to put that,
Yep.
okay? And that causes so much
'Cause
pressure.
it doesn't close that.
It doesn't close that statement.
Yeah.
So if I do this, it tells me, it says, oh, wait, it tells me exactly where it thinks there's an error. So it expects the semicolon before serial. Well, what's before serial? It's this.
Oh, hello there.
So the IDE actually, it doesn't let you upload bad code. I mean,
Right.
if you really wanted to, you could force it.
I guess, but it wouldn't work.
That'd be silly. That'd be
Yeah.
stupid. This is one of the best ways for people to get into coding because the hardware aspect gives you something tangible.
Yeah, no, that's what I like about playing with the Arduino.
Yeah, I gotta love it. But we're gonna make sure that you get the links for all of this if you want to
Yes.
buy it. And remember, these projects are inexpensive. If you wanted to buy a Nano right now, along with a string of WS2811 LEDs plus a 5-volt power source, you could do the entire thing for about $25.
Yeah.
And that will give you a great Christmas display. And you can chain these together. These strings actually have the connectors so I can chain
Attach more
strings
of
of this. And all I have to do is change in that first line of code the number of LEDs. So I have 1 strip, there's 50. 2 strip, there's 100. 3 strip, there's 150, et cetera, et cetera.
Easy enough.
Easy as pie.
Cool.
So don't forget to go to our show notes, and where can they find those, Brian?
twit.tv/KH. And after an episode like this, you'll definitely want to go check that out. And not only will there be show notes, but handy links for downloading in case you need to replay this video for all the software changes and things like that.
Right, right. Don't forget that in the new year, we are switching to a new format.
Yes.
They're going to be shorter episodes. All the first 2 we pre-recorded were not shorter.
No, it's going to take some time for us to get
We have to
used
break the
to.
habit.
But there's a reason why we're breaking it up.
We're breaking the habit. Yes, because we've got 2 episodes. Yes, because Alex hates it when we run over time.
That too.
But we're going to have 2 episodes a week, and we listen to your feedback. We understand there are some of you who want the more practical tips. You want the software tips. You
Right.
want like product reviews for things that are used in practical tech life. That's going to be Monday. On Monday, we're going to try to give you some of the more practical stuff. On Thursdays is when we're going to be giving you the build. We're going to
Yeah.
be giving you projects like this, projects like quadcopters. And I will say this, if I can't guarantee this because I never know what's going to come, but if you are so sick of quadcopters that you never want to watch another quadcopter build, watch Know How on Monday, because we will not do builds of quadcopters on Monday.
I'll be there.
Yeah. On the other hand, if you don't want to hear us talk about how you do a cut and paste in a particular program that's vexing people, then
Right.
don't watch Mondays. Watch Thursdays instead.
It's easier for us to focus on one thing per episode, and I think it'll be easier for people to find the things that they like.
Right, right. Also, don't forget that we've got a Google Plus group that's 9,500 members strong. It is just go to Google Plus and look for Know How. It is-
Search Know How,
it
pops
is-
up. You'll see Padre's giant face on there.
because someone hasn't given.
We're getting that redone. 2016 resolution. Get the album art
Only
changed.
18 months later. Yeah, how about that? Yeah, put
Yeah,
that
it'll
one
be
in
that
there. That's
face.
perfect. But go ahead and join us and be part of the discussion. Help us figure out what you want to see on future episodes of Know How. Now that we have 2 episodes, we can take a lot more suggestions and we can show off a lot more projects. So keep those projects and those pictures and those videos coming. Yeah.
That's not the only place, though. If you want to catch some of the behind-the-scenes stuff that we do, because there are other things we do outside of Know How, you can follow us on Twitter, and I am at @cranky_hippo.
And I am at Padre SJ. And our captain, is he Captain Kirk?
Captain
Wait,
Director.
hey,
Director,
Alex,
Captain.
that's command color, right? In the old series,
That's
that's
engineering.
Oh,
It's engineering. Or if you get sent.
Wait.
Do you have a last name? Because if you don't have a last name, you're probably
You're
gonna
gonna
die. That's why his name is just Hal.
Hal will be our technical director, our director for at least the next episode until he gets sucked out of an airlock. Now, okay, before we go into the parting shot, which by the way does relate to the episode because I wanted to show you some
Yes.
real world examples of WS2812s and 2811s in action. But on a personal note, Brian and I and Alex want to thank you very much for watching Know How. We love doing this show, and we couldn't do it unless each and every single one of you came back over and over again. We all started doing this podcast at Twit because it's a new medium, and we really love the fact that we can reach out directly to the audiences. So
It's almost like we can reach out and
don't
touch them out there.
Brian?
No, don't touch.
Adult supervision.
Right,
Okay.
right.
But seriously, from the bottom of our hearts, we want to wish you, no matter what your faith may or may not be, the happiest of holiday seasons. Happy Merry Christmas, Happy New Year, Kwanzaa, Hanukkah. Just
Whatever it is.
Whatever it may be, may this be a safe, restful time for you.
Star Trek Day. I mean Star Wars Day. Whatever it is.
Until the new year, I'm Father Robert Balaser.
And I'm Brian Burnett.
And now that you know how.
Go celebrate it.
Shoot the camera, Brian.